All right, so this is 4.4. After today, your polynomial show off is gonna be released on your discussion post, and it's already been visible, but it's gonna officially be posted and assigned. That's because after this, you should be able to do the polynomial show off. Okay. So we're finding real zeros. So our objectives here are to understand the factor theorem, factor high degree polynomials, and analyze polynomials having multiple zeros, solve higher degree polynomials, and understand the rational zeros test, Descartes' rule of signs, and the intermediate value theorem. So first start with the polynomial factor theorem. So the polynomial factor theorem is basically stating that your zeros, your real zeros, are the solutions to your factor form when set equal to 0. That's all that it is. So if you look right here, we have a real zero at -7, at 2, and 11. So therefore, your factors are x plus 7, x minus 2, and x minus 11. Okay. I like to say, remember, your x's are liars. So if it's a -7, then its factor is going to be a +7, and vice versa. Okay. So that's your factored form. To find the full polynomial, you would FOIL multiple distribution to get the polynomial. Okay. Does that make sense as far as the factor theorem goes? Well, let's test it out. All right. So applying the factor theorem, the first thing I'm going to do is identify my x-intercepts. So looking at this cubic function we have here, what are my x-intercepts? So we have -1, we have 1, and we have 2 are my x-intercepts, right? So based on this, having these as my x-intercepts, I can now write a generalized factored form. So the generalized factored form is f of x equals, and notice I put an a in front. The a is because I don't know if this is a stretch, a compression. Is it negative or positive? Well, I do know that a is negative because it ends negatively, but I have to put the a because it's not the exact form, it's the generalized. All right, and remember, your x's are liars, right? So if I have -1, 0, then my factor is x plus 1. If I have 1, 0, x minus 1, and x minus 2. Okay, how do you feel about getting the generalized factored form? Doable? Okay, after you have your generalized factored form, you then are going to actually find the value of your a. To find the value of your a, you're going to choose any other point on here other than your x-intercept. So for me, I usually try to go for my y-intercept because therefore I get to use zeros. Anytime I get to use 0, it makes life easier, right? So my y-intercept here is at 0, -2. In order to solve for your a, you're going to plug 0 in for x, and you're going to plug in -2 for y. So we have -2 equals a times 0 plus 1 times 0 minus 1 times 0 minus 2. And your job now is to get a by itself. So we're going to simplify and get a by itself. So we end up with -2 equals, I have 1, I'll write it all out, 1 times -1 times -2, which gives me -2 equals, a negative has a negative makes a positive. So what is my a? A equals -1. Because when I divide by 2, I get -2 divided by 2 is -1. So my actual function is f of x equals -1 x plus 1 times x minus 1 times x minus 2. So it's no more generalized, it's the actual function because I now know the a value. Okay. And I'll be done here unless it asks for what is the polynomial form of this, which means I would have to go through and distribute and multiply. Okay. How do we feel about the factor theorem? Questions, comments, confusions? No? Hmm? Factor, the factor theorem mainly comes from a graph, but if you have a table, then you're just looking for the zeros at the table. Yep, good question. All right. Now, the other thing with factor theorem is being able to just not meant from words, is can I do it from words? Okay. So it says here, write the complete factorization. So we have 7x squared minus 63/2 x plus 14. And it says that my zeros are at 1/2 and 4. Okay. To factor this, the first thing you want to do is get rid of a fraction, right? And the other thing you want to do is, in this sense, quadratic formula is always your friend, okay? So to get rid of the 2, how do I get rid of a 2? Multiply every term by 2. So we're going to multiply every term by 2. So 7 times 2 is 14x squared. This is going to cancel out. So now we're just left with 63x. 14 times 2 is 28. Okay, so now I'm here. When I look at these numbers, do they have a GCF? Can I factor anything out? Do they have anything in common? 7. Each one of this is divisible by 7, correct? So this reduces down to 7, 2x squared minus 9x, right? Yeah, that feels right. Plus 4. So for the quadratic formula, this is your A, this is your B, this is your C. All right, I'm going to give you guys a moment to practice the quadratic formula. Remember, it's x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Hey. Okay, so you have your A, your B, and your C. Can you plug in and solve for x? And go. All right, so when you're plugging in, you have x equals negative 9 plus or minus the square root of negative 9 squared minus 4 times 2 times 4. All over 2 times 2. How do we do on the setup? A negative times a negative is a positive. And 9 squared is 81. 4 times 2 times 8 is negative 32. All over 4. 81 minus 32. So we get 9 plus or minus the square root of 49 over 4. This means that you have 2 problems, right? So you have 9 plus 7 divided by 2. And you have 9 minus 7 divided by 2. I meant 4. You saw, what are you talking about? It's in your head. You saw nothing. All right, what's 9 plus 7?
16.
And 16 divided by 4 is?
4.
What's 9 minus 7?
2.
And what's 2 divided by 4?
1.
Were we correct? Okay. So that is our, so as you can see, there is a connection to everything, right? It all ties back together. All right. So we know that our factored form here is f of x equals, and it's always your original a value. And what was our original a value? 7. And then our factored form is x. We got a positive half, so our factor is going to be the opposite. Is going to be a negative half. Does that make sense? And then our other one is we got a positive 4, so our factor is going to be a negative 4. Now, this is acceptable for me. However, Pearson doesn't like that format. Pearson does not like fractions as your factors. So what you're going to have to put in on your homework is that the denominator of the fraction is actually the coefficient of your x. So what it looks like is f of x equals 7 times 2x minus 1 times x minus 4. Okay, that's what Pearson is going to want.
Question.
Yes.
What's the point of doing the quadratic formula if it gives us the zeros?
We were verifying it.
Oh, okay.
Yeah.
So we don't normally have to.
No, I was just showing you that it's all,
Okay.
no, I was showing you that it's all the same. So like, if they didn't give me the zeros, you asked about what if I didn't have a graph, how would I do it? And here it is without a graph, right? Did we have a graph? Nope.
So normally we wouldn't have to do that.
If you wouldn't see the zeros, like you wouldn't have the answer already.
Oh, okay, okay.
Yeah.
So we do that together.
Yes. Okay. So as you can see here for the Pearson answer, all you're doing is taking your denominator and it becomes the coefficient of its variable. And that's what Pearson's going to want you write it as. Okay. On our test, on our paper test, I am fine with you writing it as this, because that tells me that you understand how to factor, you did your quadratic formula correct, and you understand the factor theorem, that it's always the opposite of the zero. Okay. So just keep that in mind. All right. Questions about example 2? Okay. Do we need to try it with a 3 and see how we would go from here? Because this was a little bit different. You got to start with grouping and then go.
Maybe
We should do it. Okay. All right. So we know our answers, right? So this is our goal, is to get -2, 1, and 2. This is no longer a quadratic. So can I use the quadratic formula? No, it is a 4-term cubic. So we have a 4-term cubic. Anytime you have a 4-term cubic, you should think grouping. So going back to those Algebra 2 factoring skills, you should automatically think grouping. Grouping means I'm going to group the first 2 together, find it, their GCF, then I'm going to group the second 2 together and find their GCF, okay? So my first grouping is going to be here. My second grouping is going to be this pair. After you group, you're going to find the GCF of each one. So the GCF between 5x cubed and 5x squared is what? 5x squared. Good job. The GCF between -20x and +20 is 20. If your leading term is negative, it's going to be a negative GCF. Okay. So now you're going to factor those out. Factoring out just means you're dividing, right? What is 5x cubed divided by 5x squared? X, perfect. 5x squared divided by 5x squared is? Anything divided by itself is 1. You factored out -20. What's -20 divided by -20? 1x. 20 divided by -20 is -1. Okay, how do we feel so far about GCF factored? So again, these are just our GCF. Okay, when you factor something out, it doesn't disappear. It just no longer lives inside that grouping. Does that make sense? Just like when you leave your parents' house, they are still your parent. You just don't live in the house anymore, okay? All right, the next thing you're gonna do is factor out your, please go. You're going to factor out your common binomial. So what binomial do they have in common? X minus 1. When you factor out x minus 1, what are you left with? You're left with -20. So now you're down to 2 factors that you can set each equal to 0 and solve. Can I set each one of these equal to 0 and solve for x? I surely can. Why do they keep opening that dang door? So x minus 1 equals 0 is just x equals what? 1. Did we get that right? Yes, we're geniuses. Now we're going to take 5x squared minus 20, set it equal to 0. What do I need to do to get x by itself? I need to add 20. So I add 20 to both sides. Boom. Then what do I need to do?
divide by 5.
I have to divide the 5 before I can touch the power. Remember, we're undoing PEMDAS. We're sad mapping. So that leaves us with x squared equals 4. Now what do?
Square root.
So we get x equals, and when you take the square root of something, you make a positive and a negative. And did we get that? Okay. Do you feel comfortable being able to find those zeros? All right, so when we write this in factored form, f of x equals, your a is always your original a. And what was our original a? 5. And what are our factors?
X minus 1,
X minus 1,
X minus 2,
x minus 2,
and X plus 2.
and x plus 2. Perfect. Your a is always your leading coefficient. It never changes. Okay. So your a is going to always be your leading coefficient of your original. Okay, so we've now seen it with the quadratic, being able to find the factors of a quadratic with quadratic formula and writing in factored form. Doable. Okay, now we looked at a 4-term cubic using grouping to find the zeros and writing in factored form. These are going to be your 2 ways, for the most part, that you need to be able to confidently do it with. Yes.
Could you use synthetic division and then quadratic formula?
So you can't do synthetic because you wouldn't know your zero already.
Okay.
But if I knew a zero, then yes, I would do synthetic and then do the quadratic formula. Great question. All right. So here we are. I'm going to stop talking. Write it in factored form, fully factored form. Go. I believe in you. Okay, so when you are given a function, especially again, if it's on the calculator part, create the graph, right? Once you have the graph, you're finding your x-intercepts. Do we see our x-intercepts? Why, yes, we do. So now that we have our x-intercepts, we're going to write our function. So it's f of x equals, it's always your a, which is your leading term. What was our leading coefficient? -1/2. And now we write our factors. So I'm at -1, so it becomes x plus 1. I'm at +1, so it becomes x minus 1. And I'm at +2, so it becomes x minus 2. And that is all I was looking for.
See what I was trying to do, I was like, wait, does she want a fraction there? And then I was like, what do we need to do with that fraction?
It's your A.
She doesn't want a fraction.
It goes there. It has no choice. It has no
That's why I
choice.
said, because like I knew the points, but it was like, does she want a fraction?
I wanted you to tell me what is your A.
Okay.
Okay, cool. All right, so here we have. Now we're gonna practice it. We have no clue. Oh no, we know nothing, right? We're not just testing it. We're now gonna go full on. Can we find our zeros, right? But wait, hold up. We have some hope. It says right here, it has what? At 0, at 1. What could we do, Andrew? You said it. You said, what can we?
Synthetic division.
We can do synthetic to lead to quadratic, okay? So because it gave us 1 to start with. Does that make sense? So we can start with, our 0 is at 1. So it tells us, first we're going to use synthetic. And we know that we're going to start with 1 because our 0 is at 1. Okay, now I'm going to write out my coefficients and constants. So -2, -6, 2, and 6. If you want, you can honestly factor out the 2 first and then do it. Otherwise, just let it play itself out. Okay, so we get it going. We bring down our -2. Remember, we diagonally multiply and write its product. Vertically, we add. So 1 times -2 is -2. -6 plus -2 is -8. 1 times -8 is -8. 2 plus -8 is -6. And 1 times -6 is, and we want this to be 0 because we are down to now our quadratic. So we're down to our quadratic, which is -2x squared minus 8x minus 6. At this quadratic, I have so many options. I can use quadratic formula. I can do mental factoring. I'm going to model mental factoring for you guys. So mental factoring tells me that there is a GCF. What is a GCF here? 2, not just 2, but a -2. So I'm going to factor out -2, and I'm left with x squared plus 4x plus 3. So I'm asking myself what multiplies to give me 3, but adds to give me 4.
1 and 3.
1 and 3. So step 1, we did synthetic. Step 2, we then factored the quadratic by mental factoring. And step 3, we're now going to write our fully factored form. So our full factored form is your A. Again, what is our A? -2. And you see how it came out in the end anyway? Told you it'd come out. And then they gave us our first 0. Our first 0 was a +1, so that makes it factor A. And then the zeros that our factors that we got from our quadratic were and +3. And there is our fully factored.
Yeah.
I'm glad y'all like synthetic and mental math.
Or I like doing the one that too, so just like writing it out.
I know, isn't it like cool how it looks? I like how it looks too.
I can just it lines like so nice.
I know. I'm like, man, no. I look smart.
I wind up making more mistakes that way, but it looks nice.
All right. Was it terrible being given one of the zeros and using synthetic and then quadratic? Cool? Doable? All right.
Whoa.
Word problem.
No.
Oh no. Oh, you knew it was coming. All right. We have to do a real world example. An insect population, P in thousands per acre, X days past May 31st is approximated by the formula P of X equals 2x to the third minus 18x squared plus 46x, where X is greater than or equal to 0, but less than or equal to 6. Determine the dates when the insect population equal 30,000 per acre. Okay, so we're looking for, we have 2x cubed minus 18x squared plus 46x. And we want to know, when did it equal 30? Does that make sense? All right, this is a calculator problem because the main thing is being able to set it up. So we're going to talk about how to solve this using the L calculator. All right, step 1 that we're going to do is we're going to put this bad boy in Y1 and this bad boy in Y2. So let me grab out good old Sylvie. I'm going to turn Sylvie on. I'm going to do a quick little reset. 2nd plus 712. And now I'm going to put it in. So we have Y1. So we have 2x to the third minus 18x squared plus 46x. And we want this to equal what? 30. Okay. It also gave us parameters. Our parameters are from 0 to 6. So that means I need to change my domain from -10 to 10 to, I'm going to give myself a little wiggle room to see, -1 to 10. So I can see. It's fine. And then my Y values, when I look at these numbers, are my Y values small? No, they're not. So I'm going to make my Y a little bit bigger. I'm going to see what happens when I go to 100. And again, Miss Jones doesn't like all those little lines, so we're going to count by tens. So I'm going to go look at the graph. And oh, there we go. So this is what I'm looking at. And then there we go. So my solution points are where 30 cross the function. Okay. To find those solutions, I'm going to press second trace, and I'm looking for the intersect of those values. So I'm looking for the intersect. You're going to move your little spider, just like you read a graph from left to right. I'm going to start finding the intersect from the left. So inner is going to say you first intersect where? 130. So our first solution is x equals 1. So this is x equals 1 day pass. So if I'm 1 day past May 31st, what's my date? June 1st. So the first population of 30 is on June 1st. All right, I'm gonna repeat it again to find. So I'm gonna go second, trace, intersect. Gotta move a little bit closer to my next one. I'm gonna hit enter, let's see. And it says the next time that I'm at a population of 30,000 is 3, when x equals 3. So that's 3 days past May 31st. What is 3 days past May 31st? June 3rd. Okay. There's one more point of intersection. Move my little spider a little closer. Second, trace, intersect. He didn't stay, so closer, 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 closer. Hit enter, enter, enter. And it says that x equals 5. So x equals 5 days past. And so that put me at what date? June. Okay. A lot of times word problems are not the hardest problems. You just have to set up and know what you're doing. Does that make sense? That's what makes them the hardest. But as far as the math goes, besides setting up and planning, it's usually like the easiest as far as calculating. Okay. How do we feel? Was that terrible? They gave me an equation. They gave me a set value. And I use that to find their intersect. Yes. Anyone feels like, oh man.
So we can just stop at this point from there?
Yeah, you're done. It says, what are the days?
Oh, that's.
Yeah, we found the dates are June 5th, June 3rd, and June 1st. We found the days when their population would be 30,000 per acre. Okay, how do we feel about using technology to solve? Good? Okay, all right. That concludes today, y'all.